Code requires that all HVAC systems, including heat pumps, are designed and installed in accordance with industry standards for calculating the sizing, equipment choice, and duct layout. Here we see a diagram showing the 4 key manuals from ACA, the Air Conditioning Contractors of America. The manuals are books that software packages are then built off of that get into all of the engineering details such as heat movement, airflow, solar gain, etc., to precisely calculate the home's heating and cooling demand, select equipment based off of that, and then create a duct layout that's best going to help the home meet those loads. It starts with sizing, and that means selecting equipment with heating and cooling output that matches the needs of that specific home. Just choosing equipment based on square footage or that seems to be, just a little bit bigger just in case, it's not smart. Oversized equipment costs more to install, it doesn't dehumidify as well, and it wears out more quickly, both of those things due to short cycling. Short cycling means that the system kicks on, it runs for a very short period of time, and then turns off. For heat pumps that will be installed without auxiliary heat or other backup heating systems, you'll also need to consider sizing for both cooling and heating. Typically, we size for cooling. With those specific system types, you also want to take into account the heating needs. Please don't make the classic mistake of installing oversized equipment. It's the pathway to poor performance and high cost. Use the software that's available. Using the software also definitely applies for existing homes. It's not just for new homes. Just duplicating the capacity of an existing system in an existing home may give you the right answer or it may not. It's highly likely that when the existing system was installed, it wasn't sized using the Manual J, and there have likely been improvements or changes to the home itself, such as air sealing, insulation, windows, other energy efficiency measures that may have occurred since then as well, which would impact the size equipment that that home needs.
There are, in fact, fewer code requirements that relate to heat pumps compared to a fossil fuel system because you're not installing a combustible gas. You don't have to worry about providing combustion air, and you don't have to worry about venting fumes. When installing split systems, where there's the air handler inside and the compressor outside the building, you should consult local FEMA maps to make sure that the outdoor unit is safe from flooding. Many homes and buildings mount outside units on platforms well above grade, and this can be in response to flooding or maybe it's security. And sometimes they have to be elevated because of steep slopes next to the building. When thinking about where to locate the inside unit, heat pumps offer much greater flexibility compared to fossil fuel equipment. They come in different sizes and styles, as we've discussed, and they don't require the venting of fumes. I will say that whenever at all possible, we do want to install the air handler and ductwork in conditioned space, not like that one shown in the middle, which is in an attached garage. And that principle would apply for fossil fuel equipment as well. Ideally, an electric panel upgrade won't be needed before a heat pump can be installed, but it may be necessary, or the homeowner may want it done at the same time. If the homeowner would prefer not to upgrade the panel, an electrical load calculation can be done using the NEC electrical load calculation form for a single-family home. ACA, the Air Conditioning Contractors of America, provides a detailed guide to quality HVAC installations. Following these best practices will optimize efficiency, power consumption, comfort, and equipment life. ACA Standard 5 is straightforward and gives a good number of options for performing each task, and it has guidance for new and existing systems.